Hello ladies and gentlemen, and today I'm going to be talking about antimatter and how this new proposition that has been published by Bowder Limited explains the difference between the two. To start with, antimatter is exactly the same as normal matter, but it has the opposite charge. Thus, anti-electrons, which are called positrons, have a positive charge instead of the normal negative charge of an electron. Additionally, antiprotons have a negative charge instead of the normal positive charge. Moreover, these antiparticles can be combined together to form antiatoms. For example, an antiproton with an antielectron in one of its rings would form antihydrogen, which would have all the same properties as normal hydrogen. So let's start looking at these antimatter particles, starting off with positrons, i.e. antielectrons. Well, on the left hand side we've got the standard electron thread consisting of a negative and north poles. A positron is just the opposite thread with the positive and south poles as shown on the right. Moreover, because each of these particles consist of a single thread, then all of these properties apart from charge, which would be equal and opposite, are exactly identical. Now moving on to neutrons, and we've previously mentioned that they consist of a ring of threads with the negative and north poles on the outside, as shown in the top diagram. Thus, an antineutron looks exactly the same, but it has the positive and south threads on the outside, as shown in the bottom diagram, i.e. the threads have been wrapped the other way around to form a ring. Also, again, because each of these particles consist of the same number and type of threads, with the only difference being which way round they are wrapped into the ring, then all the properties of these particles would be identical to each other. Lastly, we have antiprotons, and these are a ring of threads with one missing, which contains a positive and south pole, represented by the gap in the rings on the right hand side. This is the opposite to a normal proton, which has a missing thread from its ring containing a negative and north pole. Unlike anti-electrons or anti-neutrons, these antiprotons can be formed in one of two ways. The bottom diagram shows a true antiproton, as it has the positive and south poles on the outside of the ring, just like an anti-neutron. Furthermore, these would be produced from antineutrons when they beta decayed and ejected a positron. Also, these antineutrons would eject positrons rather than the electrons because it has the positive and south threads on the outside of the ring, i.e. positrons, instead of the negative and north poles that a normal neutron has. However, the vast majority of the antiproton's features, most notably its charge, can also be produced if a normal neutron ejects a positron, forming a ring that also has a positive and south pole missing. The difference this time is though that the ring is still wrapped the normal way around, i.e. with the negative and north poles on the outside, and this is shown in the top diagram. Overall, therefore, we have seen that antimatter looks exactly the same as normal matter and consists of the same number of threads. In the case of a positron, it consists of the opposite thread to that of an electron, whereas an antineutron and proton rings are wrapped the other way round compared to a normal neutron and proton ring. However, we did note that an antiproton could be produced from a normal neutron if it ejected a positron instead of an electron, but this type of antiproton would not be wrapped the same way round as an antineutron. Well, I hope that you've enjoyed this video. If you'd like to know more information about this proposition, then please visit our website at www.bowder-limited.co.uk and or see our other videos. Lastly, please note that this proposition has not yet been accepted, so don't use it to answer exam questions. However, we would like to hear your views, opinions and questions regarding it, so thank you for watching.